Matt begins his site visit for a gear inspection by meeting with his customer contact. He wants to be sure to cover any potential safety risks on the site by reviewing the job safety analysis. This includes questions about what specific gearboxes will he inspect, where are they, who will ensure lockout-tagout safety, what other activities may be going on near the gearboxes with what potential risks, such as welding, load lifting, forklift traffic, or crane operation. Matt then goes through the standard operating procedure, describing for his contact the tools he's bringing: IR gun, flashlight, sample kit, camera, gear inspection report template, and bore scope. He explains that the inspection should take 30 to 40 minutes. Matt also reviews applicable oil analysis, thermographic analysis, vibration analysis, and recent maintenance history to later correlate to his inspection results.
Any questions or concerns before we go out and begin?
Sounds good.
All right.
Since the equipment is operating when Matt arrives, he uses the opportunity to check for important exterior indications. As part of his safety mitigation, Matt looks for potential hazards at the site, using his last-minute safety risk assessment, also called his Safe Performance Self-Assessment. He makes sure that he is using the appropriate personal protective equipment, such as a hard hat, safety glasses, and hearing protection. Using his gearbox checklist as a guide, he records important data that could be lost once disassembly begins. He looks for leaks and checks the oil level, oil flow meters, and pressure gauges. He is alert to notice any abnormal noise or vibration. He then uses his IR gun thermometer to check temperatures at various points around the gearbox. When a gear drive has a heat exchanger and/or an oil filter, it's especially important to check the temperature differential on the heat exchanger, comparing incoming and outgoing temperatures. Matt should also check the heat exchanger cooling area for dirt buildup that may eventually result in poor heat transfer. It's also important for Matt to inspect the filter housing and heat exchanger for oil leaks and abnormal vibration. In addition, Matt checks the filter pressure differential and dirty indicator to confirm proper operation. Matt also uses an infrared thermal imaging attachment on his smartphone. He will use this information to correlate to his other inspection results to determine potential improvement opportunities or to demonstrate good performance of the gear drive and its lubrication. Before inspecting inside the gearbox, Matt goes to the motor control room, escorted by appropriate customer personnel, to put his own lock on the off switch. For the inspection inside the gearbox, here are a few standard checkpoints. Verify the lubrication method. Is it splash or bath? Inspect oil breathers and oil fill locations to determine potential contamination control improvement opportunities. Look at the inspection cover or top of the gearbox for signs of condensation. Look at oil galleys. Is there any debris built up that could impede oil flow to bearings? Inspect closely the dynamic surfaces of gear teeth and bearings. What wear patterns do you see? Addendum, dedendum, root, tip? Record the inspection findings on the inspection data collection form. Take pictures, lots of them. You'll be able to refer to some in your report, and all of them will help you remember what you found. Take pictures of gears, bearings, and the interior of the gearbox, especially the bottom. Do you see contaminants, debris, or foam? If possible, take pictures of bearings and oil nozzles that supply oil to the gear teeth. Look for potential oil flow restrictions, like plugged nozzle orifices. It may take some special effort to get photos of gear teeth that effectively show wear, pitting, and marks on the surface. Also, compare the gear teeth and bearing surfaces against wear mode standards. Typically, gear drive and bearing manufacturers have good reference books to conduct these comparisons. Compare your inspection results with prior inspections and other measured customer parameters. This will help you to look for equipment and lubrication improvement opportunities, or to confirm good operation and lubrication. In these photos, you can clearly see evidence of corrosion and micro-pitting because the light is at a slight angle to avoid reflections from the flash. Always check your images for proper exposure and focus. It may take 3 or 4 tries to get it right. Here, Matt is using a borescope to look inside and capture images. As he told his customer, with a 3-reduction gearbox like this, he can usually get open access to one side, but to view the other side, he may need to come in through one of the ports with the borescope. In addition, since bearings may be hard to see through the inspection cover, a borescope can provide an effective means to help determine bearing conditions. With the inspection over and gearbox closed up, it's time to remove his lock in the master control room.
Well, good afternoon, Dan. We're back from doing the inspection.
At the end of his site visit, Matt meets again with his customer to give a verbal summary of his findings and recommendations. He reports finding some misalignment in the first stage, validating what he had learned earlier from the vibration report. From his examination of bearing troughs inside the gearbox, he found evidence that the first stage may be plugged a bit from the port going down to the bearing. Matt and his customer agree that conditions like these, if uncorrected, could result in a major gear drive overhaul. Together, they explore potential root causes of the observed conditions, such as the misalignment may be due to the foundation shifting or cracking, and that material in the troughs appears to be the wear from the gear teeth. So, beyond correcting the observed conditions, such as cleaning the troughs and checking and correcting the misalignment, Matt also recommends an inspection of the foundation for stability to help correct the root cause of the condition. Matt explains that he will document his findings and recommendations in an engineering service notice. Using that as a foundation, he and his customer can work together to understand the potential impacts of his findings, as well as the total cost of ownership components. Through further discussions, it becomes clear that a major gear drive overhaul could cost tens of thousands of dollars in overhaul costs, as well as hundreds of thousands in lost production. By making suggested improvements in preventive care, the customer will see a reduced exposure to hazards related to repairing the gear drive. By improving the oil contamination control, the customer should reduce safety exposure and environmental impact from waste oil due to avoided oil changes. Matt and his customer together determine that correcting the misalignment, cleaning the gear drive oil galleys, and improving the lubrication contamination control will result in costs under $10,000. Balanced against the much greater hazards and costs of lost production, that is, looking at the total cost of ownership, Matt can demonstrate that his findings and recommendations produce an excellent return on investment and value to his customer. Matt puts all this into a written engineering benefit report that documents the value the customer will receive by his inspection findings and recommendations. Matt and his sales advisor will use this report to promote our value to other key contacts at this customer. If very well received, this engineering benefit report could become the foundation of a proof of performance from this customer that could be shown to other customers to convince them that Mobil is the right lubricant supplier for them. By using the standard operating procedure as a guide, as well as the other tools described, Matt can consistently conduct these inspections and deliver outstanding value to his customer. In addition, it's always good for Matt to provide feedback to his chief engineer for potential improvements to the gear inspection standard operating procedure, or SOP. Although this video has demonstrated the key job steps in the SOP, gear drives come in many arrangements, so we may need to adapt the SOP steps depending on these variations.